limitations of chemical equations. So here, what are said to be here limitations? Limitations are nothing. Just here, you are unable to know the information related to the reactants, products, everything like a solid, liquid, gas, precipitate, right? Any heat changes observed, or that substances used concentrated or diluted, right? No information provided in the previous equations. Directly we are written like this. Suppose H2 plus O2 useless to H2O. Did you get any information in this? Any information in this? What about this hydrogen? Is it a solid, liquid, or gas? We are unable to know, right? Here, simply you are able to make them more informative. From the equation only, you are able to get all these type of information. So that information not provided by your chemical equation. That is the limitation of your chemical equations, right? So here, simply you are able to make this more informative, right? What are the problems we are facing here? They are what? There is what in a chemical equation, right? Expressing their characteristics, right? What are reactants or products characteristics? Maybe physical characteristics, or for taking the reaction between them. You may provide heat energy, or you may use different substances to fasten the reaction called as in the presence of catalyst, right? So that all the informations we can express, right? How they are here, simply using the physical state, using the heat changes, using gases evolved, right? Everything will be interpreted in the equation, right? Any precipitate formed, or here any substance is used, or heat may be provided. That means temperature increasing, or maybe pressure changes, right? These are all the types of physical conditions we are representing in the equation. We are representing in the equation. So these are the limitations of chemical equations. Then how to overcome these problems? Just following these, right? Physical state representing heat changes, indicating gases evolved, or maybe the precipitate formed, indicating by the symbol, right? Speed changes, that means maintaining the temperature or giving the heat energy, or maintaining a certain pressure, right? These all will be solved by indicating in the chemical equation. So how to make your chemical equation more informative, right? So expressing the physical state, So here, maybe sometimes use solids or liquids, or maybe the gases. For example, in the reaction of hydrogen and oxygen to produce water. Here, did I represent any physical condition here? No. So here I know hydrogen is a gas. So I am able to indicate this by using a symbol beside that as G, if it is a gas participated in a reaction. And by the reaction of these two gases, I am getting a liquid directly. So I can represent by L, right? If I use solids, for example, here by the reaction of carbon in the presence of oxygen, right? Here it is giving you carbon dioxide. Here gas is evolved. That can be indicated by the upward arrow, not as G, because by the reaction it is produced. So liberation indicated by the upward arrow. Carbon is a solid material. I can use the symbol S. Oxygen is a gas, G, like this, right? So physical conditions like this we can express. Okay. So what the symbols we can use? For the solids, we can use the symbol S. For liquids, we can use the symbol L. Gases, we can use the symbol G, right? If it is dissolved, suppose in the activity 2, I prepared a solution called BaCl2. How can I prepare? This is added or dissolved, added or dissolved in water, right? So that type of solutions represented as aqueous solutions, right? Aqueous solutions. So how do we write that? PaCl2 composition formula, and beside that we can use a symbol AQ to represent that the salt BaCl2 dissolved in water is an aqueous solution. So we can use AQ symbol beside it if it is dissolved in water. Physical conditions are represented like this, right? Then here you may observe heat changes, that maybe contents become warm or contents become cool after the change. For example, calcium oxide reaction with the water, contents become warm. So how to indicate that? Heat after the change or before the change, we observed. So here heat after the change, contents became warm, so heat liberated. So that condition we can use the symbol plus Q towards product side, right? If heat is observed, that means after the change that overall contents totally becomes cool, lost temperature, that we can write as minus Q, heat absorbed, heat absorbed. Then here we are expressing the gas evolved. Gas evolved, for example, adding of zinc metal into the water or zinc metal into the HCl. It produced a gas, hydrogen gas is liberated. We tested that gas with the burning mastic, blue color flame, pops on, burning with blue flame and pops on. So gas evolved. Production of gas in a reaction will be represented by upward arrow in the reaction. Next, precipitate formed in the reaction of sodium sulfate and barium chloride, that will be indicated by the downward symbol. It is indicating it will be separated at the bottom of liquid, downward direction indicating, right, beside the compound, right? How do we write that? For example, hydrogen gas is liberated. Beside that, I can use upward symbol like this. Don't write as gas because it is liberated gas, right? Not existing. It is produced. Then BaSO4 undissolved material separated at the bottom. Beside that composition, I can use the symbol downward. It is solid but represented as downward arrow because it is produced by the combination of liquids combined. When we combine, liquids produced. So produced quantities only represented by upward arrow, downward arrow, right? Directly they are not existing. Then after expressing the physical state, we are expressing the formation of precipitate. So already completed, right? Then here I'm going for the new, that is here speed of reaction. What is speed of reaction? Simple. Here sometimes that change maybe takes place very slowly. Change maybe takes place very slowly. To fasten that change or to complete that process within less time or limited time, what we do, we may provide heat energy, that means to change the temperature, or we may add something substance to increase that rate of reaction, right? The substance which added into the reactants, right, but itself do not undergo any change, but it increases the rate of reaction, fasten the change. So this change is called, so that substance is called catalyst. Catalyst is a substance which will be added into the reactants, but it won't participate in the reaction, won't undergo any change itself, but it can increase the rate of reaction. That is called catalyst. Or maybe we maintain pressure. So that conditions also we can represent above the arrow or below the arrow. Suppose if you find anything like this, suppose 500 degrees Celsius at 200 atmosphere ATM, right? Using something iron as a catalyst like this, we can represent above the arrow, below the arrow. So these are the examples, right? So here speed of reaction indicator like this. Then here one more is there, that is indicating the concentration. For example, while taking an acid or a base, you are suggested to take diluted or concentrated HCl Like this, they can announce what this is actually. It is the concentration, the amount of solute dissolved in the solvent. The amount of solute dissolved in the solvent will be expressed like this concentration, right? It tells you about what amount of substance is present out of 100 ml, right? For example, if you are preparing a tea, for 1 cup of tea, you may maintain 1 spoon of sugar, right? So that's 1 spoon is what concentrate of the sugar in that. If you add 2 spoons of sugar into the same cup of tea, what happened? The quantity is increased. So it is said to be concentrated. We feel very sweet taste, right? So it harden the substance, very hard to taste, right? So that amount increased, that is said to be concentrated. Enough amount is there, okay? If more than that, it is said to be concentrated, less diluted, okay? So like this we can express. That will be written as symbolically DIL representing a dilute, CONC representing concentrated solution. Is it clear, everyone? How to make your chemical equation more informative? Got it? Yes. Then we'll go for interpretation of chemical equations, right? Before that, one important topic is there. Types of reactions, exothermic, endothermic, right? Remember the examples also for these exothermic and endothermic reactions. What is an exothermic reaction? Here, exothermic reaction is what? By the chemical reaction, if heat is produced, that reaction is said to be here exothermic reaction, right? By any substances, right? Here, reactant's temperature is lower than product temperature. Reactant temperature is lower than product temperature. For example, we added calcium oxide and water. Calcium oxide and water temperature comparing with the product less. After change, that substances together increases its temperature by liberation of heat energy. For example, if you take some amount of bleaching powder or the surf into your hand, add few drops of water, you feel burning sensation. It is due to what? Heat existing, releasing. So that type of changes are called exothermic changes, heat changes, right? So here we are representing that exothermic reactions, right? So here exothermic reaction is what? Energy is liberated by the reactants. Completely after the change, that contents becomes warm. So like this, we can identify that exothermic reaction represented by writing plus symbol beside the products, right? So we can write like this. Also, that heat changes will be written by Q symbol here. Heat represented by Q. So we can write plus Q here towards product side because it is liberated, right? Add to the products as a byproduct. Then endothermic reaction. In any reaction, heat is absorbed or the reaction is taking place by absorbing the heat energy, right? If any reaction taking place by absorbing the heat energy, that reaction is said to be here endothermic reaction, right? Or how to observe? After the change, that content loss heat energy becomes cool. That type of reactions are here called endothermic reactions. So example is nitrogen reaction in the presence of oxygen or nitrogen reacting with the oxygen to produce nitrogen monoxide, nitrogen monoxide, and that content become cool. So loss in the heat energy will be written as minus heat, or you can write as minus Q also. This change is also represented as following like this. So here, loss in the heat energy, or sometimes you may provide heat energy like this also, it is not a problem. We can represent the endothermic reaction like this. See, plus Q written left side. It is absorbing the heat energy, right? Absorbing the heat energy. Like this, we can represent the endothermic reactions. Are you clear about these? Any confusion? Go to quick reaction. No confusion. Yes. So now the topic is here that heating of the content will be used by a symbol delta here. This delta indicating you providing the heat energy above the arrow. Like this also we can represent the heat reactions. Next, interpreting a balanced chemical equations. That means simply what you are able to understand from a chemical equation, right? What you are able to understand from the chemical equation, that is called here interpretation of a chemical equation. So here from the chemical equation, you are able to know the information related to the reactants products, right? By using their symbols or formulas. For example, here, if I write a reaction, right? If I write a reaction, what is, for example, Zn plus HCl useless to ZnCl2 and H2. Here, left side to the arrow indicating you reactants which undergo change itself after the reaction, after the change, that are indicating the products, right? Then you are able to know the physical conditions also. It is a solid material. It is aqueous solution, right? Aqueous solution. ZnCl2, aqueous solution. H2, a gas liberated in the reaction, upward arrow. Physical conditions also. That contents also becoming hot. So we can write heat liberation plus Q. So you can give this example as exothermic reaction, right? So these type of information we will learn from the chemical equation, right? Then second one is here, simply you are able to know the ratio of molecules. For example, any equation you can take H2 plus O2. Then one more you are able to know, is it satisfying the law of conservation of mass or not? This example is satisfying the law of conservation of mass or not? Can anybody answer me? Does it satisfy law of conservation of mass or not? No, right? Why? Imbalanced, not balanced. So here, how to make it balanced? By checking the count. The largest formula unit is H2O. Then large numbered atom is hydrogen. It is 2 right side, left side. So need not to balance that. Then I will check oxygen count, not balanced. So I need to balance hydrogen. LH side 2, RH side only 1 is there. So make it balance using the coefficient 2 before H2O. Then count of hydrogen changed, became 4. So LH side also make it 4. Now it is satisfying the law of conservation of mass. Then what to do? Here, simply the coefficients before the reactants. Oxygen, hydrogen. Hydrogen 2, oxygen 1. So the ratio of the reactants are 2:1. So this is called as ratio of molecules of reactants, right? Ratio of molecules of reactants. Whatever it may be the quantity provided by you. Suppose here 2H2, that means 4 grams or 4 units. Oxygen 16 twice, 32. So 4 grams of hydrogen reacting with 32 grams of oxygen. That is the meaning, right? That is the meaning. If you provide, sir, I will provide 40 grams of hydrogen, sir. I will provide 320 grams of oxygen, or sir, not 320 grams. I will provide just it is 160 grams, right? Here, whatever it may be the quantity given by you, that will maintain the same ratio. That means what? 40 grams to here simply 160 grams is there, right? You are providing less amount or more amount? as per the ratio. Here it does not react. Here 40 grams out of 40 grams, just it is participating 20 grams only instead of that, because here the ratio must be same. It won't participate in excessive amount. That ratio always satisfying 2:1 only. 2:1 only. So we will calculate that masses in terms of moles. So moles are what here? Right? Moles are what? That moles are nothing. If you are expressing the given masses in the grams, so unified mass is taken means that converted into grams, that is called here gram molecular weight. So you will know the molar masses expressed in grams, right? Here that H2 is taken. Here hydrogen atomic weight is equal to 1 unit, right? If that I am taking 1 unit as 1 gram, this is the molecular weight of the hydrogen atom. Hydrogen molecule, it is the meaning of 2 hydrogen atoms. So we will calculate 2 into 1, that equal to 2 grams. This is gram molecular weight of molecule hydrogen. Gram molecular weight of hydrogen is 2 grams. So this is called as gram molecular weight, indicating you 1 mole, right? Indicating you 1 mole. So it is nothing but formula unit mass. Gram molecular weight is what? Formula unit mass. So that you need to learn how to calculate the molecular weight. Okay, gram molecular weight. That will help you to find out number of moles. Here you have formula number of moles of the molecule is equal to weight by gram molecular weight. Weight by gram molecular weight. Suppose in the previous example, I said 40 grams of hydrogen. Here 40 grams is weight. Only by the composition you are able to calculate 2 into 1 is 2 grams. This is gram molecular weight. So number of moles of hydrogen is equal to, like this calculated, weight is 40 grams and gram molecular weight of hydrogen is 2 grams. So it is equal to 20 moles. This is the meaning. Any confusion in this? How to calculate number of moles? Any confusion? Ask me immediately. Did you got difference between molecular weight and gram molecular weight? Gram molecular weight calculated by using only the composition formula unit, but weight it is given in the direct relation in the question, right? So this you need to understand. Okay, in the problems we will get clarity again. Then next here, if you know that molecular weight, molar masses, you are able to know the volume of that substance and you are able to calculate the number of molecules present at a particular temperature and pressure. That means here standard temperature and pressure, STP, standard temperature and pressure. So if that molar masses are known to you, easy to calculate the mass of the substance, molar mass, next molar volume and number of moles, right? So that we will learn. Then next here, one more point is there. That is here, you are able to give a relation by knowing the molar masses. What they are? Mass relationship, mass relationship, volume relationship, right? Mass volume relationship. And next here, mass volume and the number of molecules relationship. These relationships you are able to make, right? Here, this is important thing here, right? Here mass relationship based on whatever it may be here, mass relationship or mass volume relationship, volume relationship, or mass volume number of molecules relationship. Any relationship followed by one law here. That law is law of constant proportion, which you learned in your 9th class. Law of constant proportion. That means what here? Always that reactants are participating in a reaction by following a ratio, right? Depends on the ratio of reactants, right? Not on the quantity provided by you. Suppose here sodium is reacting with the gas immediately to produce sodium oxide. Here, is it balanced one? No. Here, to balance it, what we required? 2 here and 4 here. So, see the ratio of molecules of reactants. Sodium 4 parts and oxygen is 1 part. So 4:1 ratio. Suppose 1 gram of for 23 grams is left in the air. 23 grams left in the air, right? Will it react with any amount of oxygen? Can anybody? Oxygen is available more amount in the atmosphere. Will it react with that much amount of oxygen? No. It will react with the amount that which satisfy this law, proportion concept. So 4:1 ratio, 4:1 ratio, that only it will allow, right? According to number of moles, here what the coefficient written before the formula in it, that is only equal to the number of moles. What the coefficient we are writing before formula in it, that is indicating number of moles participated by it. That means 4 moles of sodium reacting with 1 mole of oxygen. 4 moles of sodium means what? Here 4 moles of sodium means 4 into 23 grams. So 1 mole equal to what? 23 grams. 4 mole equal to what? 4 into 23, right? That is here 92 grams. So 92 grams of sodium reacting with oxygen, O2, 1 only coefficient. That means what? 2 into 16. 2 here from the subscript into 1 from the number of moles, right? So it is 32 grams. So 32 grams of oxygen required. 92 grams of sodium reacting with 32 grams of oxygen, right? So if you take that 92:32, it will give you something ratio. That ratio always it follows. That is law of constant proportion. If I change the masses, they won't participate. Suppose I doubled 92 double is what? 184. Right? Suppose 32 grams of oxygen only provided. Will it combine? No. They will follow again the same ratio here. Okay. This is law of constant proportion. So using that, always we will take ratios are same. So first mass quantity is A1 by A2 is B1 taken, reactants ratios, right? Then next ratio also must be equal. Quantities changed to another mass, right? Quantities are changed to other masses. That also ratio will be equal. That equivalent fractions, 1:2 ratio is there. Suppose masses also in this ratio. If you change, they will be give something same to you. That is only law of constant proportion. Don't worry. Here I will give you clarity in the problems. Sir, confused out, sir. No need to worry. I will give you clarification in the numericals of chemical equation. Right? Any confusion left here? Unna problem em ledu. Adento cheppandi. I will clarify that in the problems. Edaina vachindi problem? Just I need to know what you are facing here. Lack of understanding. ఏం ప్రాబ్లం ఇక్కడ ఉందా ఏదైనా? Anybody? Harshit, Kaushik, Rohit. Are there any confusion? Once refer your ninth class book to understand the law of constant proportion. It is ratio of the reactants by the balanced chemical equation. Masses ratio, moles ratio, both you will get if you balance the chemical equation. From the balanced chemical equation, take it that. Okay, right. So this is in this class. In the next class, I will discuss with you problems, right? Numericals. Example 1, right? So join immediately. I am ending this meeting.